Yes, recording started.
Oh, thank you. So good evening, everyone, and a warm welcome to Kolkata R UseR Group's sixth virtual meetup. So I am Avirup Moitra, co-organizer of Kolkata R UseR Group. So as promised, we are back again with another exciting session with another guest speaker. Before getting started, I would like to take a moment to highlight our recent group's activities. So we had five exciting sessions till date on um, two quarto, one on innovative approach to teaching data analytics to business students with R, and the last was the structural equation modeling. So if you missed out, check out our YouTube channel. The recording are available there. And do not forget to subscribe the channel and do follow us on LinkedIn. Our group is proud to be a diverse and inclusive community, welcoming individuals from all backgrounds and industries. So, whether you are a student, researcher, or professional, or simple curious about statistics, data science, and art, so we invite you to join our session, ask questions, and learn from each other. Without further ado, let's welcome today's distinguished speaker, Shannon Pileggi, the lead data scientist at the Prostate Cancer Clinical Trials Consortium, a frequent blogger and an active member of the R Ladies Global Leadership Team. Passionate about data, she excels at automating data wrangling, generating actionable insights, and simplifying complex concepts to make learning approachable and engaging. So this session introduces the project-oriented workflow concept as a foundational approach for organizing work in R. By adopting this framework, participants will learn best practices for setting up robust, scalable, and shareable RStudio projects. So Shannon will guide us through benefits of project-based organization in RStudio, cross environment file paths using base R, tips for intuitive sortable file names, clear structural for inputs, outputs, and scripts. So importance of a clean and reproducible setup. So before we get started, I encourage you all to engage actively, ask questions, share your thoughts, and make the most of this opportunity to learn from one of the best in this field. So without further ado, let's give a warm welcome, Shannon. So Shannon, over to you. So please share your screen. Yeah.
Thank you. I have, sorry, I am used to presenting on Zoom, and so I am trying to figure out how to organize my screen best for
Okay.
Teams. Yeah. Thank you so much for that wonderful introduction, and also for the spot on
It's
introduction
our
to what
privilege.
I'm
It's
about
our
to
privilege to
uh,
have you.
talk to you about today. So let's see if I can.
Yeah. So can you see a mic option there? So okay. Yeah. 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 Okay.
Yeah. So the let me see.
Yeah.
And are you seeing
Yes. Yes. Yes.
my
Yes. Now it.
slides?
Yes.
Perfect. Okay.
Okay.
So one thing that's a little bit different
Yeah.
is monitoring the chat. But I
Yes.
think I can still see the chat over here on the side. So we
Yes.
are
Yes.
good there. So
Chat is there. Also Q&A section is there. So yeah. I'll
oh,
request.
Q&A is different than the chat. Okay. So feel free to drop things in the chat or the Q&A, and feel free to interrupt me also if I miss any questions. I will share you the slides right now. So let me just exit out of here so I can drop those links in the chat. So there is the slides link. There's another link to a book here. And let me go back to my slides. All right. And yeah, so I think we're ready to dive in. If I can get a quick, just to get a baseline of what I'm working with, can you just give me a yes or a no in the chat if you are currently using RStudio projects for your daily work? I've got one yes, another yes. Okay. So a couple of you are already using RStudio projects in your daily work, and that is wonderful. I hope after this, you will more deeply understand some of the benefits of RStudio projects and maybe a couple of unexpected hangups that you might not be familiar with. And for those of you that aren't using RStudio projects, I hope after today, you'll be 100% convinced that you need to start using RStudio projects because it is a much cleaner way of working and organizing your data projects. So let's start talking about it. This work is licensed under a Creative Commons license. And it comes from the WTF material. Maybe I'll get to that in a minute. So I'm expecting most of you are not going to be actively participating in this, but if you are, I am going to expect that you have a more recent version of R, a more recent version of RStudio, and some of these packages. So where this material originates is called the WTF workshop, which WTF stands for What They Forgot to Teach You About R. That's the WTF part of it. And where this originates is that a lot of people come to R because they want to learn how to do something statistical, or they want to do something with data. But just doing statistical models and data analysis doesn't really teach you everything you need to know to be successful in R. So there's a lot of other things that aren't traditionally instructed. And that's where this book and course WTF comes in. So today we want to establish the concept of a project as a basic unit of work and apply best practices and leverage the benefits of working in projects. So let's talk about what this might look like. We're going to be organized. And all of us have projects that we are not happy with or proud of, and that we just kind of want to shut the door on. And it is okay to shut the door on your past projects and let those past projects live as a mess. So we're going to start being organized as we go, and we're not going to fret over our past mistakes. So what we want to do in this case is raise the bar for new work. So as you're doing high impact work, high friction work, work that is completely brand new, that's when we want to try to make these inroads in organizing. And when we're thinking about organizing a project, we want our project just to be self-explaining. We want to look at it and have a natural directory structure and names that really tell you, names of files that really tell you what's happening. And that's as opposed to have some sort of like README that gives really detailed instructions on how, I mean, a README is great. Don't get me wrong. Like you should absolutely have a README, but they can get out of date, right? And so having a really well organized project from the get-go will set you up for success long run. And this is up the idea, not about like best practices for scientific computing, but we're talking about just good enough practices. So if you can see in this image, this is an airplane wing and it has duct tape on it while it is flying in the air. And that's okay, right? That's what's got that plane up and running and off the ground. And that's going to be the same for your projects. If you need a reference for this, this is in PLOS Computational Biology in 2017. So let's look at a practical example. And for this practical example, we're going to simulate a project that we might want to work on. And of course, any project that we might want to work on needs data. And so we're going to talk about how to get data using your R installation as a source of data. So an R package, I'm sure you're very familiar with, it's a natural unit for distributing R code. And when you install base R, you automatically get 29 packages. There's 14 base packages and 15 recommended packages that ship with all of your R distributions. So you're going to start off with 29. And one of those packages, as an example, is Lattice. You may or may not have ever used Lattice. It was a graphing package that predated ggplot. I believe it's actually one of the recommended packages, and it does come with your R installation. So you never have to install a Lattice package. There's over 20,000 packages on CRAN right now. You can get those, and you can also get packages from GitHub. And who knows how many packages are on GitHub? And where do packages live? So packages live by default in the default library, and I'm going to show you what this looks like on my R instance in a minute. You can see all libraries available to your user for the current session with the libpass command. And you can also actually, the data we're going to look at is all installed packages. Just as a syntax aside, while we're going through this, making sure you can read all of the code I'm showing. In 2014, people started using the Magrittr pipe, and in 2021, the native R pipe was introduced. So I will be using the native R pipe, and the pipe means take this object and then do something to it. So like take the numbers 0 through 10 and then take the mean of it. I also use namespacing in my code, which tells R which function to use from which package. So for example, there's multiple packages that have a select function. When I call the select function, I will call dplyr : select to make sure that I'm using the correct version. And if you're doing namespacing, you actually don't need to submit library statements then. All right. So let me show you what this data looks like. I'm going to copy this code and open RStudio. And I am going to, I don't need to install a package. So let me just open a script here. So I'm going to use library, use this, and I'm going to use the use course function here. I can drop this in the chat if anyone wants to try it. It's going to install a directory on my computer for me. So it's just creating a little mini exercise. It says, I've downloaded this and I'm going to unpack it, and shall I delete the zipped file? And that's fine. Yes, we do want to delete the zipped file. And now on my other screen, it popped up that it said, okay, I have unpacked this set of files for you. And so now in my R environment, I'm going to navigate to where that set of files is. And it went all the way down. Let's see here. It is in this directory. So I'm going to find it. RStats. Sorry, I should have put it in a more smaller directory. Okay. And just for the speed, I'm going to open up kind of a solution so we can walk through this. All right. I'm going to be looking at the FS package, loading the FS and tidyverse packages. And the first thing we're going to look at is my lib paths. So where does R search for packages on my machine? And I have two lib paths specified for various reasons as I've been playing around with my own R configuration. And it also might depend on if you're on a Mac or Windows operating system. So you can see that I have some packages that go to my program files directory, and I actually have some packages that go into this app data directory. So which one of these is the default? Well, the default is going to be given in the by dot library. So when I am working right now, I am by default calling all packages that are available here. And in case that looks really unfriendly, we can expand that out using the FS package to see what that link actually looks like all the way expanded out. So you can see that my default right now is going to my program files. But this session of R can access all packages that are listed in either directory. So now we are going to look at all of my installed packages. So here we go behind the hood. I love doing this exercise and live workshops. It's always fun to see who has how many packages installed. And so you can see here that I have 226 packages installed. And when you use this as Tibble package or as Tibble function, it gives you this convenient data frame version of this information. So it tells you the package, where it's actually installed at, the version of that package, what version of R it depends on, some imports, and other metadata about that package. So now we have some data we can work with for our project. And by the way, one of the reasons this is the data example we use is because if we teach this workshop as part of a fuller day workshop, another component of what they forgot to teach you about R is learning about your R installation and how to manage and control it. So how many packages are installed? I have 226 in other workshops. I've certainly seen people have 500, 800, or 3,000 packages installed. It gets crazy sometimes. And so let's explore the packages. So again, I told you I was fiddling around with my R installation, and you can see that my base and recommended packages were installed in my program files, and all the other, for the most part, all of the other packages I'm using are installed in my app data. And you can look at other information from this, like what proportion need compilation. And here we see 43% of this, and we can look at what version of R were they built on. So I have most of mine were built on 4.40, and some of mine were built on 4.41. All right, so that's the data that we are going to be using as a framework for our next exercise. Are there any questions before I switch back over to the slides? I'm happy to see you, Saranjeet. Thank you for participating again. Seen Saranjeet in 2 workshops this week. I see some dots going on.
Lovely to see so much of you, Shannon.
I know.
I'm trying to type a question, so I'll just try to finish it off. But yeah, if others have questions, sorry.
Is there a link to this R project? So yeah, well, okay, first of all, this is actually not yet a project. So I kind of wanted to first talk about the pain of using things that are not in R projects. So this is a collection of files, and you can tell that it's not a project because up here it says project none. And over here, there's no R cube, which would indicate the root directory of the project. So this is a loose collection of files, and yes, there is a link to that. So this loose collection of files can be found, again, by using this code, like use course will allow you to install it. And if you don't want to install this directory, you can also go to that link that I'm dropping in the chat, which is where it's hosted on GitHub, so you can work through it yourself. There's a question that I don't want to answer, but thanks, Sarah G. I am not the all right. Would you recommend install packages versus renv install versus pack package install? I think there are some circumstances in which you might have advantages with some of these functions. I will say that if you are working in a renv project, I don't want to say anything because I'm gonna get it wrong. I'm just going to leave it as there are advantages for certain of these functions for certain scenarios when you're doing installation, and it might depend on what exactly you are doing and what your needs are for which package installation method you're using. But I'm happy to follow up with that, Energy. Are there any other questions? Okay. So now we have explored our installation, and that collection of files was not an R project. And one of the things that was like a little painful about that, did you see like how long I fiddled to like open that collection of R files? Like I had to like navigate to where it was and find the directory and all of this. So it wasn't very cute. So let's talk about what happens if we use a project instead. Project-oriented workflows are amazing because they allow you to work on more than one thing at a time, allows you to collaborate effectively and communicate, and it really allows you to start and stop quickly, which is super important for my job because I am jumping in and out of multiple projects all day long. And how it works is that you have a dedicated directory for your project, which is this now a thing. It's like an RStudio project with a capital P. It is a proper project. And you'll probably be syncing up with a Git repo as well when you're doing your work. And one of the things that a project-oriented workflow really helps with is understanding of your working directory and how to write paths inside of your project. So if you've seen any of the work, if you're familiar with Jenny Bryan's work, Jenny Bryan has a very popular quote that if the top of your script is set WD RM list equals ls, Jenny will come into your office and set your computer on fire. And if this is your current practice, like that is okay, but we want to show you that will help you with you with the future you, and you collaborate with others. And one thing that's really nice about project-oriented workflows is that it helps all of this problem to go away. Now, if you aren't familiar with what this does, RM list equals ls, I'll just do a quick demo for you in my current R session. So let's see here. So list equals ls is going to, no, I didn't mean to do it. ls is going to tell you all of the objects in your environment. So I have a df packages offset object, and also now I have something called a list object that I just made. And rm is this function that removes objects from a specified environment. So when I say rm list equals ls, I am going to be removing all objects from my global environment here. And now my global environment is now empty. And so sometimes people start a script with this because they think it is simulating the idea of working with a blank slate. But there are some limitations to this. So maybe I'll give you all a minute and you can type your answers in the chat. You just saw that the rm command removes objects in your global environment. So when you do this, which of these things would still persist in your R session after you execute that command? All right, Saranjeet says she used RM all the time when she started using R, and I think that's how most of us did. I mean, and honestly, when I started using R, RStudio projects wasn't a thing. It didn't exist, right? So like we didn't have many choices. You are welcome to put your guesses in the chat. It's just a guess. I see some correct answers, and there's more out there. I'll tell you that. Okay, so RM list equals ls, it removes objects from your environment, and only two of these things here are actually objects. So summary being created as head is an object. X is the numbers 1 through 5 is the object. These are the B and E are going to be the only affected items here. So B and E are going to be taken out, and everything else affects your R session and will persist when you execute RM. So calling, attaching a package, setting an option, setting a language, attaching a package again. These are all things that will persist when you execute that RM command, which means RM really isn't actually truly starting R with a blank slate when you execute this command. And it makes it really hard to troubleshoot and debug and figure out when weird things are happening, why they are happening. So, so what does it mean to be an RStudio project? You are now in your directory, you're going to have a file with the extension .rproj. And an open project, it's actually going to get its own dedicated instance of RStudio. It's going to get its own R process. It's going to have a working directory set to your project directory and a file browser pointed at your project directory. And this dedicated instance of RStudio and R process means you can have multiple projects open at the same time. So like your computer could look like this. You could have 8 RStudio projects open at the same time. Not that I recommend it. I'm sometimes often between like maybe 3, but I try not to go more than 3 at a time. But you can have multiple projects open at the same time. You should be committing your rproj file to Git because it helps keep that metadata about that project together. So again, you're going to have with the projects, many projects open. You can have your own file, your own directory, your own Git process, your own R process. All right. And I've mentioned this word blank slate a few times now, and I don't know if it's really explicitly understood what blank slate means. The blank slate is a way of restarting R with a fresh R session, such that none of these things that we talked about here would persist in a fresh R session if you truly restarted R with a blank slate. And restarting R with a blank slate is so important to be able to debug when things go wrong. So unfortunately, it's actually not the default option in RStudio to restart with a blank slate. And there's two ways you can control that and make it your new default. And every time you reinstall RStudio, you'd have to remember to do this. Or like not every time you upgrade RStudio, but just install it for the first time. So one way you can do that is do it via the use this command, use this blank slate. And the other way you can do that is in your RStudio menu. You can go to Tools, Global Options, and down here. So it's the section on Workspace, and you want to make sure Restore R Data on Startup is unchecked, and Save R Workspace to R Data on Exit is never. And I would highly suggest that you go ahead and do this. And if you do this, it is a different way of working. So when you open R, you're probably, if you have never done this before, you're probably used to seeing your environment populated with objects from your prior R session. And this would no longer happen anymore. But I will tell you that is a very, very good thing for you that it won't happen, because it forces you to make reproducible work. Are there any questions before I move on? Okay. So I highly recommend you configure R to have a blank slate. And what this allows you to do is restart R with a fresh environment. And the way you can actually restart R is go through the menu option, so Session, Restart R, or you have some keyboard shortcuts, like on Windows, it's Control Shift F10. And I restart R very, very, very often when I'm working. It's especially important if you're like installing a package on the fly to try new work. You want to restart R before you start tinkering with that package. Otherwise, things can get a little tangled and confused. But in general, when things get weird in R, you restart R. And so how do you make a project? One is you could have a new folder, like you're creating a project from scratch that doesn't exist yet. And so then there's two ways. You can use this command, use this create project, or you can navigate through your file menu, file, new project, new directory, new project. What we have now is we have an existing folder that we want to convert into an RStudio project. And so then you can still use the same function from use this, create project, and you can still navigate via the menu, file, new project. So I'll just show you that real quick as an exercise on how to convert this session to a project. So again, up here in the top right, it says project is none. And we just have a loose collection of files. You see there's no .rproj extension here. We just have readmes and .rs. So I'm going to go to File, New Project. Existing directory. And I'm going to find that rstats directory. And I want to convert this to a project. So I'm going to create a project. And a few things should happen now. So number one, let's see here. We have a few new files in this directory. So you can see here, I now have a .rproj file, which is where R leaves instructions to itself. I have a .rproj.user. This is a file that you would not commit to GitHub. This one should be in your git ignore because that's user specific. The rproj you would commit. And then we have this like cube up here, which we didn't have before. The magic of the cube, if you explore and go deep, deep, deep into different directories of your project, this cube will take you back up to the root of that project, the top level of that project. And another thing that we have here is you've seen this drop-down menu before. Can't remember what it said, but something about no project. And now this drop-down menu has my 8 most recent projects that I can choose from to open. So now that loose collection of files has been converted to a project, and that makes life much easier. Just so you can see, you can figure out what the working directory of this project is. It points exactly where this cube takes you to the top level of this directory. Any questions?
So the create project would essentially also set the directory for you.
Yeah.
The working directory.
Yeah,
Irrespective of where you were. Yeah.
You would have to specify.
Yeah, I mean, yeah.
Yeah. Mm-hmm. Yeah, but the use this create project does exactly what the point and click operations do.
Right. Yeah.
Any other questions?
I mean, I hardly convert some existing directory to a project because I try to start with a new project, but I can see this can be also very helpful, like if you have something existing and you want to convert it into a project. But
Yeah.
does like when you're working with R, does R not so if you start working with it, does it not automatically create a .r project file associate?
No,
Okay.
not
It
unless you
won't.
tell it to. Mm-mm.
Okay.
Hi Shannon, Jyoti here. I had a question around our project. So if I've cloned certain repository from say GitHub, then does it automatically create our project? Because in that case, I do observe in the top right corner that the name of that repository from the GitHub, that name exactly appears in the box on top right corner. So does Git clone automatically create our project?
I think it depends on the method you use for that, right? Like there's a million ways you can clone projects and a million UIs that help you in a million whatever. I personally always use this create from GitHub, and the default from that is to convert that directory structure into a project if it's not already.
Okay.
Probably the menu-driven commands, if you do it that way, would have the same default also. Any other questions? So one thing that makes working in projects really advantageous is this idea of creating really nice paths for your objects, not necessarily objects, but for things that you work with in your projects. So I guess no one's on Twitter anymore, but here's a very old screenshot of a tweet from 2022 stating that there's a paper that was published about research code quality and execution, and whether or not these files on the Harvard Dataverse were actually reproducible. And there were a lot of errors that could be avoided if people didn't hard code file paths. You can see here, file path or output error. There was a huge number of them. And it's really tricky to figure out file paths sometimes, especially how to make them robust. So let's talk about how you know where your files are and how to make those file paths robust within an RStudio project. So we want to practice safe paths, which means they are relative to a stable base. And I encourage you to use file system functions. These are functions specific to the creation of file paths. So a lot of people might be tempted to use like character string operations on them, and that you may be able to do that in some circumstances. They're just going to be more robust if you actually use file system functions. And so one really great package for working with file system functions is FS package. If you haven't used it before, I highly encourage you to check it out. There's some great functionality in the FS package. And another one that can help, especially within the context of RStudio projects, is the here package. And where the here package really shines is in making project relative paths. So let's talk about what a stable base means. So if we are in a project directory, we can use the here package and the here function to access our raw data that's in our data directory. And you can either do this with a comma syntax, saying that this data is nested in the data directory, or you can do this with the / syntax. And just note that if you're working in RStudio and you're doing this with a / syntax, if you press tab, it will auto complete for you, which I did not know for way too long. You can also look at the user's home directory. So if you didn't know, every user has their own home directory. You can find that with the fs function path home. And maybe you're looking at some official location for installed software. If you want to kind of dig into that more, I encourage you to read the Gapminder README. So absolute paths may be tempting to write, but I wouldn't hardwire them into your scripts. You instead want to try to form them relative to a stable base. So for example, I might direct to some test.csv using an absolute path, but actually this directory is related to my home directory, right? My home directory might be user/Shannon, in which case I don't need to hardwire this absolute path. I could just say it needs to be formed relative to my home directory, and I can do that using the fs path home. So there's different ways you can create stable bases depending on what your objectives are and where your things live. But here's magical for items that live inside of your project. But I think we need to do a little bit of exploration to kind of really illustrate its clear advantages. So here builds paths inside of a project. You always have a top level working directory when you use here. And then when we execute things, it forms those absolute paths for you. And another reason why this is so important is because if we use here when we form paths, it's going to work on my machine, but it's also going to work on your machine because it's relative to that project directory. It's going to work if that working directory is in a subfolder. It's going to work for RStudio projects, our packages, and it's going to work with knitr, R Markdown, and Quarto. The here package is designed to work inside of a project, and so hopefully all of you are doing that within the context of an RStudio project, but it can be in other contexts as well, like an R package or a folder with a file named .here. And just so you know, here does not create directories for you. That's your job. It just writes paths to directories. And I want to just make sure we're clear on the different types of paths that we are going to be exploring in the next exercise. So in the first item here, we have an absolute path where I write out the full location of where a file is saved. On the next item here, I'm writing out a relative path. That's a relative path to the working directory established by the RStudio project. So RStudio project establishes a working directory, and I can use this to access my data if I'm working in the context of an RStudio project. I can also use an relative path within the RStudio project directory. So wrapping this with here, in this case, will result in the same thing. In which case, you're probably puzzled about why we actually need here if these do the same thing. And I'm going to hopefully illustrate that in the next exercise. So I am going to do this. I'm going to call another project. I put that in the chat for you if anyone wants to do this along with me. I'm going to I'm going to open up a fresh RStudio session so it doesn't try to nest it in that one. That's all of my old stuff. All right, this is a fresh RStudio session. I'm going to execute use course, and I'm going to namespace this. And it's okay to delete that zip file. And now I am opening up another RStudio session. All right, and so now I have my fixed paths exercise. And you can see here that I actually have 3 RStudio sessions open simultaneous. So I've got my Explore Library session, my No Project session, and my Fixed Paths session. And that's the benefit of working within RStudio projects. So to get started with this exercise, I'm going to go over to my R directory, and I'm going to open the first script named O1. All right, and the first exercise we're going to do is we are going to try to access the data that's located here. So we have data installed packages.csv, and we're going to do this by writing out the hard coded path. So you can see my directory name here. If I click on these 3 dots, it'll allow me to go to my full file explorer. So I can just copy and paste that long name. And now I believe that's going to go right here. Got an extra slash. So now this is actually where this directory is saved on my computer, and I have my hard-coded absolute path, and I should be able to read in the data from this folder called installpackages.csv. I'll go to my environment here so we can just confirm. So dat, I've read it in, and this was an example that had 874 packages installed, and we could take a look at it if we want to go on a little time hop and explore Ginny Bryan's package installation from 3.4. But now we want to do this again, not using an absolute path. So we want to do a relative path, taking advantage of our project working directory. Again, here we are looking in the data folder. So I'm just going to prefix this with data /. And again, I should be able to execute this code and take a look at that data again. So that executed without error. And so we've taken advantage of our project directory, working directory, and confirmed that we've got 874. Let's restart R. Probably should have done that last time. So again, that's that blank slate option. There's nothing in my environment. Now we want to do this, a relative path that using our project directory instead of our working directory. So again, here, this is taking advantage of our current working directory. Right? Our current working directory is this. Now we're going to do it by taking advantage of the project directory using the here function. So I'm going to call here. I'm going to call data installed packages. So this is taking advantage of our project directory. I'm going to read in this data again, and we're going to see those 874 rows again. So 3 different ways of accessing the data set with 3 different types of paths. And you probably might be confused about the difference between 2 and 3 and why the here package even matters, which I can illustrate in the next example walkthrough, but I'll take any questions if there are any questions first. So I'm going to go ahead and restart R. And the O2 and the O3, these are equivalent scripts, just one's using a Quarto document and one's using an R Markdown document. They're going to do the same thing. I'm just going to open up the Quarto document. All right. So the first thing we're going to do is we are going to predict what things we're going to get when we compile this Quarto document. So we are going to ask the Quarto document what our working directory is. So you can see I have this like really long, complicated directory name. Sorry about that. So predict first in your head what's going to be our working directory for this Quarto document. Then we're going to tell this R session to do what I told you never to do, set your working directory. I'm going to tell it to move one folder up from wherever I am using the ... notation. And then I'm going to say, well, what was that result? What is my working directory now? And then in a final third chunk, I'm going to recheck what my working directory is. And I think just hold that thought one more. There's a question about, can you please iterate the benefit? I believe you meant up here. And so hold that thought, and we're going to hopefully show you the benefit of using the here by the end of the next exercise. So let's see if we get what results we get when we render this document. All right. So I don't know if you are surprised by this or not, but when I get my working directory for that Quarto document, the working directory for that Quarto document is the R subdirectory. That's where that Quarto document lives. So it is not at the top level of my project. The working directory for that Quarto document is in the R subdirectory. When I ask Quarto to go up one folder from wherever I am, up one folder would just be right here, right? So we're going to go up one folder. We're going to get out of that R directory. And we got our working directory back just by going up one level. And now, in a final last chunk, we ask our Quarto document, what is our working directory again? And it goes back to the R directory for our working directory. So your default working directory for a Quarto document or an R Markdown document is going to be wherever that Quarto document or that R Markdown document lives. And if you are trying to change that default, setting your working directory only persists for that specific chunk. It is going to reset for all chunks. It might be like a little deep. It might take like a little bit to sink in, but let's show how this problem is alleviated by using the here package. So now we're going to go to exercise 3. So when we go to exercise 3, we are going to hard code our path to access our data. And this should absolutely work. I think I can still paste that in. I have an error set to true on my knitter options here, which means that even if I hit an error, this document should still render and show me what the error message is instead of not render at all, instead of like halt rendering. So I'm only going to fix item 1. I'll render it and I'll show it to you. So we are going to hard code that path, and we're going to get a rendered document, and it should be work. All right, so here is our absolute path that we hard coded, and we've got the head of our data set. Again, I didn't modify the relative path, and so this didn't actually work. These are hit errors, right? So let's go work on this next one. So we've got our absolute path. What if we tried to do our relative path, path relative to the working directory without using the here package? It might be tempting to do something like this. And go back up one, right? So our data lives in our data. And actually, if I execute this, like it works in line, right? I've got my dat2 and it works in line here. But what happens when I go to render it? Need to update over here. So here it's updated to data/installed packages.csv, but it says it can't find it when I render my document, because remember, the working directory for this document is now the R folder. So I need to actually go one level up out of that R folder. So actually, to get this to work, I have to go up one level, right? Like I have to go, I'm in R, then I have to go up one level and then go into data. So now I'm going to render this. And go check out the result over here. And now that I've gone up one level out of my R directory back into my data directory, now I can use that relative path for my working directory in order to access this data. No one wants to do this. No one wants to have to go back up and then back down, right, in your directory structure. So an easy way to fix this is to use the here package instead. So instead of doing that, getting up and out nonsense, I'm going to use here. I'm going to say relative to my project directory, I want to go into data and then installed packages. So let's render this now. And you can see now I have gotten into access to the data. So all of this to say, the point of the here package is that it really plays beautifully with our Markdown and Quarto documents, as where those R Markdown and Quarto documents live, set the working directory for that document. So instead of using the directory of where that document lives, you're going to be using the here package to access the project directory to form your paths at runtime. Does that answer your question in the chat now? And are there any other questions? I think the first time I saw this, I was a little blown away. I didn't realize what was happening with my working directories in Quarto and Markdown documents, and just really helped me to better understand where the here package shines and what I can be doing with my file paths. All right, well, then I will move on. So if you can, I highly encourage you to keep your data inside of your project directory. It makes things easy in terms of workflow. But I actually, at work, I don't keep my data inside of a project directory. It's not feasible for my workflows. Our data has to live in a central location that can't be pushed up to Git or GitHub, that like everyone needs access to. And so there are different options you can use if your data can't live in a project directory. Things that you can do are create symbolic links, and there's FS functions that will help you do that. You put the data in an R package. If it's a stable data, I certainly have internal data in an R package that's stable, that doesn't change much. You can use the pins package. There's data warehousing options. And you can also create stable paths to that data that just work for users, which is what we do internally at work. So another part of projects is how you name things, and your names for your projects do matter. Let's go into some deep thoughts. This is a quote from Romeo and Juliet, a famous passage. What's a name? That which we call a rose by any other name would smell as sweet. But that is just not true for file names, right? A name is actually really important for your file names. And so you do want to be thoughtful about how you approach these. And this quote is not originally from me, it's from Danielle Navarro's project structure sides. So names matter, and the way they matter is we want names to be machine readable, human readable, and we want them to sort nicely. So what features differentiate our sad names from our happy names? I'll give you 1 minute to put some ideas in the chat. Lots of good things in the chat coming in. So for differentiation, people have noticed the use of underscores and hyphens to differentiate words. They've noticed avoiding special characters except for underscores and hyphens. People also noticed be logical, right? Like some names are more self-explaining than others, the use of case. And some people noticed like not starting a file name with a number or actually using dates is actually a good thing. So let's put a framework around this. Great observations. So for names machines like, don't leave white space in your names. Like you can probably do things with file names that have white spaces. In the past, I have had some like earlier versions of like Knitter and things. I've had some like really hard work with like file names with white spaces. So depending on what you're doing, machines just don't like white spaces. Don't leave white spaces in your names. Use letters, numbers, hyphens, and underscores. That's it. Don't use any special characters. They can have special meaning and do weird things when you're trying to do file system operations. You want to be consistent with case. So some operating systems will treat lowercase a and uppercase a the same and some differently. And you want to use your separator characters wisely. So an example way you can do that is to use your underscore to separate different chunks and a hyphen for words in the same chunk. And these are going to create names that allow you to do operations on these names which is why we want names that are machine readable. Beyond being machine friendly, we want to do have names that humans like, right? So a name should contain some information on the content or anticipated context. You want to think about creating a slug from user-friendly URLs to kind of tell you exactly what that URL is pointing to. Should be concise and meaningful and usually appended to the end. And then you want names that sort nicely. And you're going to get things to sort nicely if you put something numeric in it. So if you left pad with zeros for constant width, like instead of writing 1, I would write 01. You want to use the ISO 8601 standard for dates. That's the YYYMMDDD, sorry, 2Ds format. It is the only way to write dates. If you are not writing dates in this format, you should be, because it's going to give you beautiful logical sorting. And so it's going to put your file names in some sort of chronological or natural ordering that's common sense. And I love this quote from Jenner D. Bryan that she has an unwavering commitment to the ISO 8601 date standard. People of all nations can parse her freezer with her chicken stock. If you need any justification for using this date standard, you can go to this website to find that information. So examples of file names that are sort nicely and that you can do regular expressions on. We're going to prefix those file names with numbers. They are going to kind of have the same stub, like file system practice, and maybe an adjective at the end. So like, is it a comfy, a Jenny, a Spartan? And it allows you to like make names where people can just guess what the file's purpose is, and you don't really need a long explainer or README to direct people to understand it. And then it allows you to do operations on those file names, so you can find files that have the word explore in them. And it also allows you to turn those file names into data very easily. Especially when you use these intentional delimiters via underscores and hyphens. And if you have those numbers in your file names, it's going to allow you to make those sortable in a way that you experience them in real life. There is a question in the chat. Is there an advantage of using 01 file name versus 1 file name? So I would always just default to the 01 because you might think you're not getting up to 10 files, but you probably are going to get up to 10 files. I have yet to find a use case for like my project work where I needed to name things with 2 zeros. Like I don't use 001. I never get up into the hundreds of files for any given directory. But sometimes I get up into the tens of files. So I like 01. So for names matter, we want our names to be machine readable, human readable, and we want them to sort nicely. This is something that's easy to do now, and you're going to get huge payoffs as your projects get more complex. So let's talk about what those more complex projects might look like in terms of a project structure. So we want to break our logic and output into pieces. And beware of like very monolithic large scripts that attempt to do everything. Anytime you're working in a project, especially as it grows, you should be thinking, what part of this project can be compartmentalized to this part that can be run in isolation and queued up into other parts? And how you compartmentalize can model your data science process, right? We have compartments for importing data, for tidying data, for transforming data, visualizing them, modeling them, and communicating them. All of these are separate compartments, and you can break up your project into these compartments. And so if we break up our project into these separate compartments, separate R scripts, R markdown files, Quarto documents, whatever you need for that objective, it's way, way, way better than having one script that does everything. I promise. And as an example of what this might look like, you might have a script that helps with your importing process, a script that helps with your wrangling process, one for your modeling, one for your visualizing, and one for your communication. And you're also going to have artifacts at each of these stages. So some of your project artifacts are going to look like the raw data that you import, maybe some data that you generate as a result of your wrangling, some model fitting data, and things like that. And these are separate project artifacts, right? They go into their own compartments, And so having them saved into their own compartments is way better than having them saved into one large R data file. And so this might look like your importing step, you're working with raw data, your tidying step, you're working with your data.csv, then you're getting out some results from model fitting, and you're usually using that to visualize things like in figures. And so these are our data artifacts that are also compartmentalized. And so you should think about organizing your project as each compartment has its own input, its own code, and its own output. And they kind of feed into each other, right, in different steps. And when you compartmentalize it in that way, it makes it easy to modify or re-execute individual steps as needed without having to dig into something that's like everything.r. So for example, we might be doing things with our raw data to make sure it conforms to our expectations. Or we might be wrangling our data, our raw data, and get our data.csv that we use. We're going to use that wrangled data to do some modeling and get some other things out of that model. Then we're going to use those modeling artifacts to make some figures. And then we're going to be using those figures to make a report. So if you can compartmentalize different components of your project to input, code, and output, it's really going to make your project a lot easier to navigate. There's a question in the chat. Would you interchangeably use dashes and underscores in file names? Like raw dash data.txt or raw underscore data.txt? I think that's up to you. Either way, I would just be consistent in how you use it, which is exactly what Priyanka said. Thank you for the response. All right. So if you want to do this on your own time, you can do the exercise that helps you turn a report into project organization strategies. It's going to walk you through your input, your code, and your output, and how to organize this into a project. But instead of doing that, I would be very happy to take any questions.
Yeah, Shannon, am I audible? This is Abhirup here.
Yes.
Oh, I hope you are done with your part. Okay. So thank you for your uh, session. Yeah. And I can see the session is quite interactive, and we are really privileged that you have joined with us. So if anyone wants to ask questions, so please unmute yourself, or you can raise hand, or you can put your questions on chat box.
Thank you for that, Saranjeet. There was no question, just a comment.
I mean, I am inspired to use here more now. I've heard about it, but I don't always remember to use it. But I think, yeah, I'll use it going forward. Sorry, I'm talking in a
Amazing.
room which is totally quiet, so I'm disturbing people. So I'll just mute myself. Sorry.
That's great to hear. Thank you. Thanks, Priyanka. Well, thank you all so much for having me. You're welcome
Okay.
to follow up with any questions. I'll type my email in the
Okay.
chat.
So please ask your doubts or questions. Is there any questions? Please unmute yourself because we are about to close our session here. So we can wait for 1 or 2 minutes, right, Shannon?
Sure. Yeah.
Okay. 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 In meantime, can you send me the Quarto presentations, and if it is possible from your side, share the project, the R files, the .r
Yeah.
extension file. Yeah, you can share it to me. Okay, or you can share it in our mail.
Okay. No problem.
Okay. Okay. Okay, so we are about to close our session here today. Uh, so a huge thank you, Shannon, for sharing your expertise on project-oriented workflows, and to everyone who joined us today. So it's been an insightful experience learning new ways to organize, structure, and enhance our projects for maximum efficiency. So also, so let's growing and connecting and supporting each other on our journeys. So for that, stay tuned for more updates, and we look forward to seeing you at our next meetup. So thank you all.
Yeah. Thank you. It's so nice to connect with people all over the world. I appreciate the invitation.
Okay, okay. Then bye bye.
Bye.
Okay.